Hey everybody, I am Veda and I'm an AI/ML solutions architect. And if you're wondering what an ML architect is doing here, I was a serverless solutions architect. I just switched teams a couple of months ago.
And we'll convince her to come back to serverless at some point soon, I'm sure. Today we're going to talk a lot about stream processing with Lambda. We have a couple different use cases. The first one is based on Kinesis. The second one is based on Kafka. This is a 400 level session, so we're going to get into the meat of things pretty quickly and jump in pretty quick. It's also a chalk talk, and so that means we really want feedback. We want to be talking with you. Sometimes we start to go too deep into a specific use case, so if that happens, we'll talk to you after, things like that, so don't feel bad if that happens. But definitely want kind of audience participation, so we'll get that started. How many people are using Kinesis today? What do we have for Kinesis folks? All right, what about Kafka? All right, cool. And then aspiring, not really using any today, but want to. Okay, got a few. And then any DynamoDB streams people. It's tends to be a minority. Wow, that's a lot of DynamoDB streams people. I love that. Okay, cool. Well, awesome. Well, let's dive straight into it. And what I've done today is, rather than start with kind of an intro of what Lambda is or how Lambda works with streaming, we're just going to jump straight into a use case. You can ask questions as we go. And so from a logical architecture standpoint, what we have is fleet of vehicles sending data, right, vehicle telemetry data into our stream. We're then going to do some enrichment on that stream. And then we have an app that is going to detect if we have some flat tires. We also want to archive that data to a data lake to do, longer term analytics, predictive modeling, things like that in the future. In a real world use case like this, you would probably have IoT Fleetwise or IoT Core or something like that before you're going into Kinesis. But we only have an hour, and we really want to focus on the fun stuff. So we're just going to forget about that for now. We're just going to talk about the Kinesis data stream. So we then have a Lambda function, which is doing some enrichment and normalization. So think about things like, reporting temperatures. You might get them in Fahrenheit and Celsius. You might get miles traveled coming in from some cars in kilometers, some cars in miles. Normalize that data, make that data consistent, and then send that on to the normalized stream. And then, so we have that second Kinesis data stream there of that normalized data. And then that's connected to Kinesis data firehose, which is going to archive that data up to S3. So those of you that might have been playing around with Kinesis and Lambda for a long time, you may have written a Lambda function in the past that connected a Kinesis data stream to a Kinesis data firehose. These days, you can just do that. You don't need that Lambda anymore to push from Kinesis data stream into Kinesis firehose. You can just connect those two, which is really nice. And then we have our flat detection app, which is another Lambda function. So that Lambda function is basically looking at those records that are coming in and looking at those tire pressure monitor sensors on those tires, saying, hey, is this within the healthy range? If not, we're gonna send out a notification, let people know that that's happening. So I've got this up and running, and have some different metrics around it. So the top row of metrics is all that first Lambda that you saw, right? That enrichment Lambda there that is enriching, normalizing that data. And that second one, the second line there is the Lambda function that is doing the flat detection. So have two different Lambdas. They're up and running. You can see kind of duration-wise, the enrichment one is taking a bit longer than the TPS one, right? The enrichment one is just kind of doing more things. We got iterator age on the right there. There's an interesting one right here. So number of records in each batch. So I don't know how many people are familiar with what your CloudWatch metrics look like for a Lambda function when you're consuming from a Kinesis data stream. That's not a metric you get out of the box, right? That's not one of the metrics that's there. But that metric matters a lot. and it matters a lot when you think about the performance of your stream. So, one of the knobs that you have to kind of tune the performance of that Lambda function is that batch size, right? And that batch size, when you set it, is a maximum batch size. So if there's not enough messages coming through the stream, coming through each shard in that Kinesis data stream, you might be getting batches that are smaller than that max size that you set. And so it's good to have visibility to that. And so in this case, I'm publishing that metric myself using the embedded metric format within CloudWatch. If you're not familiar with the embedded metric format, it basically gives you a way that within your Lambda function, you basically just log data in a special format, and then in the background, CloudWatch turns that log data into a CloudWatch metric. And so now I can look at things like, all right, what's my average duration? And I can relate that to how many messages I see there, right? So right now I'm getting batches of 15, 16 records, things like that. I can increase that batch size, or maybe more data could flow through there. I could be getting larger batches, which you would imagine my duration would go up. But it's really like, how much is my duration going up compared to how many messages we're seeing there. So any questions on what you're seeing here? Yeah, go ahead.
Can you compare Lambda with other serverless options like message and process?
Yeah. So the question was around like comparing Lambda, and I'll probably switch back to this use case. Comparing Lambda to other options, other serverless options for doing kind of analytics, right? So you have things like Kinesis data analytics allow you to run like Flink jobs over data within your Kinesis stream. Oh, sorry, off the microphone. And it is powerful, right? Like Flink is very powerful, especially if you want to do calculations over kind of larger windows of data. So you can do tumbling window calculations with Lambda functions, where the Lambda function basically takes care of kind of accumulating state for you across a number of Lambda executions in up to a 15-minute window. But if you want to go bigger than that, that's where you really need to look at something like Kinesis data analytics. You use Flink to do that sort of thing. The downside to things like Kinesis data analytics and Flink largely is that you have to kind of learn Flink, right? Like Flink is not, at least to me, not trivial to pick up, right? Like these are kind of specialized streaming analytics frameworks, and there's just a fair amount of effort to learn that and build that. Whereas, the beauty of Kinesis connected to a Lambda function is, that Lambda function there, it doesn't even have, well, it does to write to that one, but if it wasn't writing to another Kinesis data stream, it wouldn't even need the Kinesis SDK, right? The Lambda event source mapping is taking care of getting those messages off Kinesis and executing them on my Lambda function. All I need to think about is the business logic to process those messages. And so that's the beauty of it. It just is kind of easier to use there. Any other questions, other thoughts?
What are your suggested retry mechanism when a Lambda would throttle there?
Yeah, so the question around kind of retry mechanism if that Lambda kind of were to throttle. So, the error handling with Kinesis and Lambda functions is very rich. There's a lot of kind of different options. What we're looking at here is kind of a zoomed-in version of a single Kinesis shard being processed by a Lambda function. So just a reminder, like Kinesis, the way Kinesis scales is you have one stream and it has multiple shards in it. By default, you have a one-to-one mapping between those shards in Kinesis and concurrent Lambda executions. So think about a Kinesis stream with 8 shards. You can have 8 concurrent Lambda functions running against that shard. We've zoomed into a single Lambda function here. So, basically the Lambda service, the event source mapping, is polling that shard once per second getting a set of records and then synchronously invoking that Lambda function on our behalf with a batch. There's an option to do parallelization factor. If that's turned on, then we're creating sub-batches within that batch of records in that shard to scale out to more Lambda functions, and we can talk about that more in the future. If that Lambda function returns successfully, the Lambda event source mapping is basically moving the marker of how far it's read into that shard, and we'll then start the process over again. If the Lambda errors, the behavior very much depends on what you've set. The default settings are to retry until the records error, basically age off of the string. You don't want those defaults. There are lots of reasons to use different settings for the error handling, but almost no one wants those defaults, so I encourage you to take a look at your error handling and do something different. If you have report batch item failures, you are using a special response format, and it's not that special, it's just JSON, to say, hey, I failed at this record, right? So like the Kinesis ESM gives me 20 and I fail at 10, yeah.
Actually, this is one thing I have never tried before. So how does it work when there are several failures in the batch? Can you, because it says failures, I just noticed that you can report more than one.
Yeah.
What will happen?
So like it really is it's going to react based on the earliest failure in the batch, basically.
Okay, so it will continue.
It's going to continue after.
Basically, it doesn't make sense to report more than one.
Exactly. So if you think about like going through and like sequentially processing the batch that you've gotten, if you run into an error, just report it right away rather than going through and finding more errors.
It's just kind of confusing that you can report an array, but then
yeah, but it doesn't
make sense.
It doesn't really make sense.
A quick question on that.
Yeah.
So if there's a poison message, will the entire batch is discarded?
So we'll get to that.
All right.
Question of like if there's a poison message, what happens? The other thing that I'll point out here that is really important to understand is you reporting back that batch item failure is gonna like kind of trigger the retry flow within the Lambda function. But when you look at your Lambda metrics, that still counts as a successful invocation, right? And so that's like an important thing. You want to make sure you have that in your log so you realize that these retries are happening, even though when you look at your Lambda function metrics, your Lambda function is returning successfully. So that's an important piece with your batch item failure. So then another optional thing that you can turn on is bisect batch on function error. And what this does is this basically is trying to help you isolate a single record within the batch that is a failure. So say I have 100 records that come in, record number 24 fails. If I fail that batch, and let's pretend for a moment I don't have report batch item failures on, if I fail that batch, what batch item bisect batch on failure is going to do is split that batch in half. Try the batch of 50 messages, it's the first 50 messages, it's going to fail. It's going to split it again down to 25 and 25. Try the first one of those again. It's going to keep splitting down until it gets a single record that fails. And then it's going to continue on with maximum retries and maximum age of the message. So you can tell it how many times you want it to retry this message before, whoops, where'd it go? Before it sends it to a failure destination. So one very important thing here, we like come up with these terms and then we use them over and over again. So failure destination, when you configure a Lambda event source mapping with a streaming event source with Kinesis with the Dynamos DB streams, you can set a failure destination on the event source. And that's what you want to do in this case. With Lambda functions, if you're invoking them asynchronously, you can also set a failure destination. That failure destination is different. It only comes into play when you are asynchronously invoking that Lambda function, which is not what's happening in the streaming use case. So I see customers mistakenly create that failure destination, that SQS queue to send those failures to, on the Lambda function itself instead of the Lambda event source mapping. And if you think about like a SAM template to define that, it's like the difference between, you know, those 2 lines being here and those 2 lines being here. So it's really minor, so you just want to make sure you get that.
And same goes for the maximum size though.
Same goes for the maximum retry. Same thing. You want to configure that there, not on the Lambda function itself. Any other questions on the failure side of things? These are basically all the same for DynamoDB streams as well. These are mostly not there for Kafka today, right? So Kafka event sources are different as well. So some other things to think about in like a use case like this. There are a number of ways that you can try to kind of make these things more efficient. You could imagine, you know, some older cars don't have tire pressure sensors on them. So you might be getting data from cars that don't even have tire pressure data. You know, for this flat detection one, if there's no data there to look at, like why are we even bothering looking at that record? So there's a feature that we launched relatively recently, which is event filtering that happens on the Lambda ESM. So with event filtering on the ESM, I can set a filter criteria that says, hey, only messages that match this filter criteria do I want you to pass along to my function. So it's really just building on the magic of that Lambda event source mapping. So that Lambda event source mapping, you're already not paying for the compute to pull that Kinesis stream for you. We're doing that for you, and you're only paying for the compute to launch your Lambda function. And so with this, we're cutting down on that even more. So if you only need to look at half of the messages, now you can filter those out ahead of time and use this to do so. Important note there is this happens before the batch size and the batch window are applied. So I talked about batch size before, so batch size is really important. It's a good way to get kind of additional efficiencies. Batch window is a way to kind of get efficiencies at times when you have low volumes of data going through the stream. It basically says, wait this many seconds if you don't have a full batch before you send me a batch, right? So maybe you have a batch size of 500 messages. If the stream is busy, there's 500 messages in there all the time, it's not gonna look at batch window at all. It's gonna just say, hey, I have a full batch of messages and send it onto the Lambda function. But then maybe overnight you get a lower volume of messages going through. If you set a batch window of 60 seconds, if there's less than 500 messages in that batch, it will wait up to 60 seconds to accumulate more messages to have a larger batch and then send to your Lambda function. And that all happens after that event filter. Any questions there? Does that make sense? Yeah?
Does this reduce the cost of reading?
Yeah, so does this reduce the cost of reading Kinesis? No. So there is like a small charge for basically doing the get records from Kinesis. You're still gonna see that charge regardless of what the filter is set. You just won't see your Lambda function executed as many times.
Wasn't it so that for normal stream consumers there was no extra charge for the get records and it was only the enhanced panel? Because I think the main difference between enhanced panel and normal consuming was that you don't pay for the data you consume.
That might be right. I have to look at the Kinesis pricing. So the question was around, there's two types of Kinesis consumers. So there's standard Kinesis consumers, and what Anna was saying is she thinks there's no read charge. And then there's enhanced fan-out consumers. Enhanced fan-out consumers are under the covers, they're using an HTTP2 connection to Kinesis and getting the messages pushed to that Lambda ESM, so it lowers the latency considerably. So normally that Lambda ESM is polling Kinesis once a second, and so if you think about latency, you can't get below basically 1 second plus whatever the duration of your Lambda function is. with like a normal consumer, EFO can help bring that down. EFO definitely has additional charges.
If I'm not completely mistaken, which I might be, I think for the standard consumers, the normal data ingestion is for free. Then if you have the extended data retention, then you start paying. And for EFO, it's the other way around. So you pay for the normal, but then it starts to be free. But I don't remember how many days. There was that kind of.
Well, there's also the on-demand side of things, right? So if you turn on Kinesis on demand, then you're paying per read versus paying the other way around. Kinesis on demand also like an important thing to think about. So historically, with Kinesis, you said, give me 10 shards on this stream. And then if you needed more, you said, hey, raise it to 20. You did that scaling yourself. Kinesis on demand scales that for you. And so that's another option for you to consider. With Kinesis, using that on demand, the thing to keep in mind is that one-to-one mapping we talked about in terms of the concurrent Lambda functions that are going to execute related to the number of shards in the stream. And so with Kinesis on demand, you have the possibility of the number of shards increasing quite a bit. And so you just want to keep that in mind in terms of, one, making sure you have your concurrency limits on Lambda in your account high enough to be able to handle that scale that could be driven by that on-demand Kinesis stream. But then also, what are the things downstream of Lambda that you're calling, and can they handle that like kind of big burst, right? So you want to think about that whole chain and whether or not they'll be able to handle it, because that's important as well. Yeah.
So when you opt in for more consumers, I mean in terms of Lambda, will the order be guaranteed?
Yeah. So the question is, when you have more consumers with Lambda, is the order guaranteed? And the answer is yes. So the order is guaranteed per shard, right? So basically per shard, you're going to get, a batch of records, it's going to execute, you finish those successfully, it gets the next batch, and that's how you guarantee the order. If you turn on parallelization factor...
I guess no then, right?
No, parallelization factor, you still guarantee order, which is awesome.
Okay.
So parallelization factor, basically what you can do is, instead of having this one-to-one relationship here, we can switch it so that we can have 10 Lambda functions, up to 10. And so, if you think about this going from parallelization factor of 1 to parallelization factor of 2, this is what it looks like. You might think like, oh, you probably lose ordering then, but you don't lose ordering, because of what we're doing is we're creating sub-batches based on the partition key within that shard. So you can almost think of it as like virtual shards within one shard, is almost how I think of it. The important caveat to that is that if you turn on parallelization factor to help with throughput, but the reason you need it is that you have a single hot partition key, it won't help you, right? So if every record that flooded into this shard has the same exact partition key, turning on parallelization factor isn't going to do it.
A similar question. So what is the best strategy to select the partition key then? Random go with some number?
What's the best strategy to select the partition key? So if possible, use a partition key that is related to your use case, right? Like a user ID or something like that. If user ID is bad because you have like a user that could have like a whole flood of things, think about additional things that you could add to it to like give that randomness. You could use a GUID, but like, if you don't need to, if there's some like normal piece of it that you could use, I say that's better to use.
Just coming back to the on-demand one, because that's again one thing that I'm interested in. So maybe a bit of criticism or question or whatever. So am I getting this right? That basically what it does, it over-provisions your stream based on the information it gets from the 30-day window before that. So if you had like a peak of 20 shards, it will just over-provision it to 40 shards, and that's where you're going to stay if that peak doesn't come down.
Yeah, so the question was around on-demand Kinesis, and like it basically uses like a 30-day look-back window. The question was, if it sees a peak that drives usage up to 30 or 40 shards, is it just going to stay there? When I look at it, it seems to me that it scales down faster than 30 days, but it doesn't scale down to like very low, right? Like it'll stay at like 8 shards, 10 shards, like it'll stay a bit
The thing,
higher.
like the picture I have in my mind when somebody says on demand is basically the dynamo pictures, you know, with like
Yes.
going up and going down. This doesn't happen here. If you have a traffic that goes up and down during the day,
Yes.
you basically are not gonna have like, okay, now we have more shards and now we have less shards.
Uh.
You are always
You're
gonna
gonna
have
stay
the
higher
max.
up. Yes.
So that's kind of something
Yeah.
that you need to
Yeah,
keep in mind.
it does not aggressively scale down,
Yes.
right?
Yes.
And the thought there, at least talking to that team, is like they're not charging you based on the number of shards, right?
Yeah, but still
it's
it's
like
very
it
expensive.
drives this, right? So it is definitely, there's kind of a trade-off there of getting that kind of on-demand scaling. You're definitely paying a little bit more for it than
Basically,
provisioning
my
the
bottom
shards.
line maybe that if you know your traffic, which is kind of predictable, and you know that
Yeah.
okay, at the peak I'm getting to 20 shards, I can just myself provision it to 40 shards, and I will pay much less for that
Yes.
stream than I would pay for the on-demand
Yes.
stream. So
Yep.
I guess that's,
Yeah.
that's
If you know your predictable traffic, you'll save money by provisioning for sure.
right.
Yeah.
One of the provision key, which is also always a problem. I thought about like doing like some sampling on the data itself.
Yeah.
It's like a feature. And then you want to reach like a unified distribution of the data itself. Like if, for example, if you expose something like that, you don't need to do the pre-assumption about your partition key.
All right. So I'm not sure I follow. So talking about like wanting to sample your data in order to figure out the right partition
Yeah.
key. Yeah. It's interesting. Like the partition key thing. Like most of the time you can find something native to your application that makes sense. Every once in a while it does make sense to just employ a GUID to like get it there. The question there is like, do you need in order processing? And then like, what's the thing that you need to be in order on, right? Because if the thing you need, back to our use case, if the thing that you want to be processing in order on is the VIN of the vehicle identification number of the car, that's got to be your partition key. Otherwise, you're not guaranteeing it, right? And so, like, partition key relates to that in order processing, and so you just have to like keep that piece in mind. Sometimes you can, do things like add like an extra element to it that can help, get more randomness into that partition key.
Just thinking of, for example, if you have like users that have like a different color of shirts, right?
Yeah.
So during some period, you can get like different colors, right?
Yes.
So if you have like one advance during the sampling period, figure that out, that could help.
That's true. Yeah. No, that would be an interesting option for sure. Let's see. All right. So a couple more minutes to spend on Kinesis. Any burning questions? Anything folks want to kind of talk through? I could talk a little bit about kind of performance tuning and sort of best practices there. Here's my, I have to go back. It's my step-by-step for performance tuning a streaming Kinesis workload with Lambda. Number one, where I say, make sure you have a working system. When we looked at that error reporting, right, you could see a lot of the way the error handling works with Kinesis and Lambda involves retries. So if you have errors happening within your stream and you want this high performance, low latency processing, they're gonna slow things down. And so like the first thing is to just make sure you have like a working system. And if you want the lowest latency possible, what you basically want to do is avoid all of those error handling options that we give you, and you want to log your own errors to CloudWatch and deal with them later. It means that you might log things and then process them later out of order, right? So there's like a trade-off there between trying to successfully process as many messages as possible versus trying to process as fast as possible, right? And so there's a trade-off, and you need to think about what you want to do. If you want that lowest latency possible, you want to avoid all of those retries and basically just kind of swallow your own errors. Then you need some way to measure to know if you're improving your performance. So time to process one message, time to process your average batch message. Have that there. Make sure you know what that's looking like. Tune the producer. So if you own the thing that is producing the data, take a look at that. Make sure that that is working as well as it can. And then tune the Lambda function. So the number one thing that I see improve performance is this. So memory size of 128, the base memory Lambda function is slow, right? It will be faster if you give it more memory. There's a great utility called AWS Lambda Power Tuning. It allows you to run a Lambda function with a test payload over a whole bunch of different memory ranges and see where the performance is. Because when you increase the memory of a Lambda function, you also increase the CPU and the networking throughput of that Lambda function. So I just increased this from 128 to 1.5 gigs. I'm using AWS SAM and SAM Accelerate in the background. Basically, that is watching this file, this SAM template file, and it's updating through CloudFormation right now while we talk. And so if we switch over to my CloudWatch dashboard, kind of as we talk, it should start to, that was the enrichment function. Hopefully, we'll start to see some improvement on the performance there. So that's the first thing. Make sure you test that with a batch. Use Lambda Power Tuning, that really helps. Then tune the event source. So again, batch size. Test with different batches. See where that sweet spot is in terms of the batches. And then enhanced fan out. We talked about that a little bit already. If you want the lowest latency possible, enhanced fan out really helps to lower that latency an additional amount. And then parallelization factor as well, right? So we can go back in, we can make another change. Where's parallelization factor? So down here, we got parallelization factor, and really, you shouldn't make multiple changes at once, right? You should just be making a single change and then test. But we only have an hour total, and I need to turn it over to beta. So we'll just do that quickly. Come on.
Yeah,
it will get faster, I swear. No, it's still deploying. But that should speed up and that should go faster. But I want to, any last questions on Kinesis that we can answer real quick, and then we're going to switch over to Kafka.
Do you recommend using Kinesis producer library in Lambda to write the Kinesis async?
Would I recommend using the Kinesis producer library to write to Kinesis from within Lambda?
Tell the truth now.
I don't. I haven't. You could. I should look at it a little more closely to see how it works. You need to be a little careful of the async nature of the Kinesis producer library and make sure you flush those final messages before Lambda leaves. In this case, I just used Kinesis the batch put items. At least in Python, it's pretty straightforward to use that, so I haven't used the producer
How
library.
would it even work with the daemon and all that should be running with the producer library?
Yeah, that's the thing
It's
about
a
the
shady.
producer. Yeah, the producer library is kind of weird if you're using it in non-Java languages. It's basically, unless things have changed, I haven't looked at it in a bit. It's basically like running a daemon in Java and then wrapping it with other languages. And so if you're writing your Lambda in Java, maybe it makes sense. If you're doing it in another language like Python, like I was, I'm not sure it does make sense. And there we go.
Yep.
So you can see, we're having an average duration here around 87 milliseconds, and we're down to like 20 milliseconds, right? And that is, that's not even the parallelization factor kicking in yet. That's just moving that Lambda function to have